Hi, this video explains how to get gain margin and phase margin from Bode plot and hence to calculate the stability. So first we will see some terms. Gain crossover frequency, that is omega GC, phase crossover frequency, omega PC, phase margin and gain margin. Gain crossover frequency is the frequency at which magnitude plot crosses 0 decibel, and phase crossover frequency is the frequency at which phase plot crosses minus 180 degree. Gain margin is the gain to be added to reach 0 decimal at omega PC or phase crossover frequency, and phase margin is 180 plus the phase angle at gain crossover frequency omega GC. We will do this with an example. I have a open loop transfer function in the standard form 3.5 upon j omega into 1 plus j omega upon 5 into 1 plus j omega upon 20. That means I have the corner frequencies at omega equal to 5 and omega equal to 20. As described in the previous video, I have drawn the Bode plot, that is magnitude plot and phase plot. So my magnitude plot gives me a slope of minus 20 decibel in the beginning up to omega equal to 5, and at omega equal to 5 to omega equal to 20, I have a slope of minus 40 dB per decade, and from omega equal to 20, the slope of the magnitude curve is minus 60 dB per decade. And corresponding phase plot is also done. Now what we have to do is we have to get the gain crossover frequency and phase crossover frequency. So the gain crossover frequency, by definition, the frequency at which the magnitude curve crosses 0 decibel. So this is my gain crossover frequency, almost 3 dB, 3 radians per second, and phase crossover frequency is the frequency where the phase plot crosses minus 180, which is 7 radians per second. Now to calculate gain margin at phase crossover frequency, that is this value, find the difference in the gain from 0 decibel. That is, the gain here is almost 12 to 13 dB. We will say 13 dB. So I have to add 13 dB to make it 0. So this is my gain margin. That is 13 dB is the gain margin, and phase margin is at omega GC. Get the angle, it happens to be minus 140. So 180 plus minus 140, which is 40 degree, that is the phase margin. And if both phase margin and gain margin are positive, the system is stable. Here both phase margin and gain margin are positive, so the system is stable. Thank you.